Hello my friends and business partners from around the world, welcome to my channel. My name is Rafael. I'm an electrical engineer, book writer, business English coach, professional translator and bilingual teacher of mathematics and physics in Brazil. And in this video we're going to see a problem of Petrobras 2014. The exam was originally written in Portuguese, the official language of Brazil, but I took the time to translate it to English to show to a larger audience. You're going to see how electrical engineering problems are like in Brazil. To follow the exercise, go to the description of the video. Let me read the problem. A three-phase electric induction motor is running at full load when, at a certain moment, it loses one of the phases of its supply. In these conditions, it can be observed that the letter A, B, C, D, and E. I'm not going to read the alternatives. Let's see how we understand the problem and then we judge the alternatives. Okay, first of all, to begin solving this exercise, we need to understand the torque angular velocity curve. This is the torque angular velocity curve. Okay, the motor behaves like this. If the velocity decreases, then you can see that if the velocity decreases, the torque increases. What does this mean? It means that if the torque increases, the velocity is going to end up increasing again. And if the velocity increases, the torque is going to decrease. And then it's going to ensure that the velocity is going to decrease. Then the motor is going to attempt to draw the same power as a three-phase motor or a single-phase motor. Why do I say single-phase motor? Because when I have three phases, the motor behaves as a three-phase motor. But if I lose phase C and I have only currents IA and IB, we can prove that IB is going to be the negative of IA. Then IB is going to be the return of IA, and the motor is behaving as a single-phase motor. Okay, this helps us understand what's going to happen after we lose one phase. So, before losing the phase, when the motor is still a three-phase motor, we have the power. The three-phase power is equal to the square root of 3 times the line voltage. Here I chose VAB, but you could have chosen VBC, for example, just to illustrate, and IA conjugate. Okay? And we proved here by analyzing the graph that the three-phase complex power is equal to the single-phase complex power. And then the single-phase complex power is going to be equal to VAB times IA conjugate. Okay? But I'm going to add an index here, a subscript, to differentiate the initial current to the final current. Are you guys understanding everything? Okay, so if the power as a three-phase motor is equal to the power as a single-phase motor, what we can do is to simply make them equal. Okay? VAB times IA being equal to VAB times IA AF. Okay? Do you guys fully comprehend what I did here? I can cancel this with this, and then here is the complex conjugate of the current, but we don't need to operate with the complex conjugate. We can simply use the current, and then we are going to end up reaching that the value of the initial current is equal to the value of the second current divided by the square root of 3. And then we ultimately reach that the initial current is equal to 57.7% of IA final. Okay? So, what is the conclusion that we arrived at? We arrived at a conclusion that the motor to operate under the same power is going to have to draw from the power supply 57.7% more of current. So the final current is 57.7% above the initial current. Alright? So this is the conclusion that we get, and we decide that the letter A, you can go to the description of the video to check, letter A is the correct alternative. Okay, my friends, this was the video that I wanted to make. I hope you guys enjoyed it. If you want to talk to me, simply go to my channel and contact me. If you want to have a lesson with me, I am going to add to the description of the video my WhatsApp number, and you can contact me, alright? Okay, my friends, this was the video that I wanted to make. I hope you guys enjoyed it. Goodbye!